Radio TV phono nut here, and this is another one from the back file, a Majestic 5-tube table radio from about 1938 or 39. It's not as, the files on this one are not as old as a couple of the last ones I put up, but this goes back several months, and it's one I'm going to have to let go of. The chassis, someone did just enough to it to make it play on the strongest local station, but there were all the capacitors needed to be replaced, a good many resistors needed to be changed, there was a lot of rotten rubber wire that had to be replaced. You know, it's a 5-tube transformer powered set. It works pretty good, but the cabinet needs to be redone, and I don't do cabinets. We'll leave that for somebody else.
Begins Saturday at 8 Eastern on Fox. Your local hometown radio station, WMER, has the funeral announcement brought to you by Northern Roofing, 2510 A Street in Meridian and in Jackson. Here's Doug Gottlieb. WMER.
A social distance.
Yeah, the highly overmodulated Southern Gospel station.
Slowing the spread of coronavirus. Here are ways to stay in contact.
Watch the video and hope you get something out of it. And if anybody would like to own this radio,
dedicate a song on the radio.
Then there's a link in the video description where you can make that happen.
Call your healthcare provider before going to their office. For more info, visit coronavirus.
Okay, the Arvin turned out to be a turd. The Temple turned out to be better. Let's move on to number 3, the Majestic. This one's going to need some cabinet help as well as chassis help. So let's get it apart and see what the chassis looks like, and if that's successful, we'll glue the cabinet back together. A 5-tube chassis with a power transformer. Power cord looks like a replacement, but the power plug got cream puffed at some point. But that's no problem. I should have a plug here I can put on it. Okay, plug is replaced. We have continuity across the power cord. So let's pull the rectifier tube and power it up and make sure the transformer is good. Alright, we have 540 volts across the high voltage winding. That's pretty good. And there's no excessive current draw, so we're getting off to a good start. Alright, 5.8 across the rectifier filament, and that's good. Alright, transformer passes all tests. Now I think the next thing to do would be to go ahead and change out this filter capacitor. Looks kind of crusty, as do the leads going into it. I'm sure it's bad. Alright, we'll bring this up slowly because I know you like to hear filter hum. I'm running it at about half AC input, and I'm hearing interference already. That's already a good sign.
For your values, a conservative organization.
And it plays.
Securing our borders. Glad you did.
It actually doesn't have that much filter hum.
Gallagher for AMAC.com, or just call 855-624-6229.
Air Jackson here. Like you, I'm consigned to my home, spending time with my family, and one thing we enjoy right now is watching uplifting movies.
But it has got some filter
I have
hum.
the answer, introducing patterns of evidence, the Exodus.
So we'll go ahead and replace that and take care of that issue. Now just for fun, I'm doing a B+ check, pre-cap change, and we'll check it again after it's serviced. Right now we have 180 volts coming off of the rectifier cathode, and it started motorboating. But we're not gonna panic just yet. We're gonna replace the capacitors and then go from there. We have a mica mold tubular electrolytic capacitor that looks original. Our red and white tracer looks to be 8 microfarad, 300 volt. Red is 12 at 300 volt, And our yellow is 20 microfarad at 25 working volts. And black is common. Okay, here's our terminal strip in place. I had to add some wiring because the existing wiring wasn't long enough. Now, when you're working on these older AC radios, especially from the 1930s, you want to be careful because lots of times the common terminal of the filter capacitor does not connect to actual B- or circuit ground in the radio. In some sets, you'll have one capacitor where its negative connects to circuit ground and the other negative does not. But let's look and see what they're doing in this set. As you can see, our first filter capacitor comes off of the cathode of the 80 rectifier tube, then connects to the speaker field coil, which doubles as a choke, and the other end of the field coil connects to the second filter capacitor and also your B+ line of the radio. Alright, our filter capacitors here have a common negative, but they're not connected to the actual circuit ground or chassis. They're connected to the center tap of the transformer, and let's see where it goes. We trace it up here. And it connects to a resistor, which is our grid bias resistor for the control grid of the output tube. And then we have a resistor that connects between chassis ground and this center tap of the transformer, and we also have a filter capacitor that connects between chassis ground and the center tap of this transformer. We have a grounded cathode, and so that's how we're obtaining our bias voltage for the audio output tube. So yeah, you want to be careful of those kind of things, or else you might blow a filter capacitor. And in this case, for our filter capacitor that's in our grid bias circuit, the plus side of the capacitor will connect to chassis, which corresponds to this yellow lead on our old capacitor, which is a 20 microfarad 25 volt. Alright, our B+ went up to 225. Okay, I'm having trouble with this tuner here. And now we've lost reception, so let's see what's going on here.
We will stop the spread of the coronavirus.
Alright, rotten wire coming out of the IF transformer, touching the can and killing everything.
On the beat, KISS 104.1, 5.9 FM, 9:10 a.m., and our radio. In the Gallagher listener special box, click on. What do they need? Don't need a receiver, don't need a safety, don't need a corner, whole line set.
Alright, checking from the negative of the filter caps to the control grid of the output tube. I'm getting about 10 volts, so yeah, this capacitor is leaky, and that won't do our output tube any favors. Yep, leaky to the max. Disconnected, got about 60 volts on the other side of it, so yeah, that's going to have to go. And changing that coupling cap brought the B+ up to 260 roughly. And now we're motorboating again. That IF transformer wire was shorting out again, and it sounds much better. Alright, there we go. This thing is very touchy. And our B+ went up. And our positive voltage went away from the grid of the output tube. So what was happening is that positive voltage was causing the tube to turn full on, which was drawing more current, which was lowering the B+ voltage. Now let's go over what caps do what in here. These electrolytics are your filter caps for your power supply. The smaller electrolytic is the filter for the bias voltage. The capacitor we just changed is couples the plate of the first audio tube to the control grid of the audio output tube. This cap here connects from the plate of the audio output tube to ground. And its purpose, one thing it does is help shape the tone of the radio, but more importantly it helps prevent oscillation from taking place within the audio output stage. This capacitor back here couples the output of the volume control to the control grid of the first audio tube, and its purpose is to block any possible DC voltage that might be coming off of this volume control and keep it off the control grid of the first audio tube. This big honking cap here connects from the B+ line to ground, and its purpose is to strip any RF off of the B+ line, shunt it to ground. You may be asking, well, can't the electrolytic power supply capacitors do that? No, not really. They make a poor bypass cap for bypassing RF because of their high power factor. So you need a paper cap to do that. And this capacitor is the screen grid bypass capacitor for the IF amplifier tube. Once again, its purpose is to pass any RF that might be present on the screen grid to ground. And if any one of these two bypass capacitors opens up, especially if they open up, you could have unwanted oscillation and whatnot. And the same thing could happen if they become severely leaky. If they become very, very, very leaky, they could short your B+ to ground, and then that could cause trouble too. And this cap over here is the AVC bypass capacitor or filter capacitor, whatever you choose to call it. And once again, its purpose is to keep RF off of the AGC line, and if it fails, that could also result in squealing and undesirable noises. Now, this plate bypass cap for the audio output tube, if it opens, once again, that could cause strange oscillations. They're originating from the audio output stage, and if it shorts, it could cause damage to your power supply as well as burn out your audio output transformer, so you want to be mindful of that. And I have that audio tube plate bypass cap disconnected, and we're passing about 36 volts through it, so yeah, it's leaky, no surprise. And that plate capacitor had been replaced before, yet another layover and solder with the remnants of the old part still in place. So we're going to have to clean this mess up before we install the new part. Alright, here's our capacitor replaced. I cleaned up the output transformer plate lead, and there's a 3 meg resistor that connects between the plate of the output tube back to the plate of the first audio tube, a feedback circuit, I presume. Now, I had to do it this way. I don't particularly like doing it that way, but the lead wasn't long enough to go back over here. And I need to find a little piece of heat shrink tubing and take this back off and insulate that. But for right now, it'll do for testing. Alright, so we're still going in a positive direction. Now I want to take each one of these bypass capacitors loose and see what the effects are. And yeah, it's motorboating. And we had 52 volts on the other side of it, so even though it's very leaky, it was still functioning somewhat in the circuit, but with it open, it's just going to motorboat and oscillate, so you know what that does. And when making a connection to a terminal, we strive to make a physical connection, as in run the part to be replaced through the terminal to be soldered to, bend it over and crimp it down, so therefore it's mechanically stable, and then we'll solder it. None of this laying it on top of laying the replacement component lead on top of a terminal or another lead and putting a drop of solder on it. That's not going to get it. And there it is, soldered in place, never to cause trouble again. Now, let's pull this 0.1 off of the B plus line and see what effect it has and see how much voltage is passing through it. Alright, pulling this cap loose produces no noticeable effect, and many radios don't even have this cap, but a lot of manufacturers included it just to be on the safe side. What do we got passing through here? 160 volts, so that was pretty leaky. 200 going in, 160 coming out, so that one's, I got a feeling that one would probably just short out if it was used for too much longer. Okay, that takes care of all of the detrimental capacitors with high voltage on one side of them that could cause problems if they were to short. Now this one here, I could have made its lead shorter by pulling it over this way, but then it would have been close to these other leads, and I didn't want any possible interaction with any grid leads, so we're leaving it like it is, basically like the original one was situated, and there's no chance of that shorting out to anything. And this one here, unfortunately, I had to J-hook it because the capacitor I had, the leads weren't long enough on it, but it's in there. So now that leaves us the AVC filter and the coupling cap off the volume control, and it'll take care of the capacitors. It's amazing how much more room you gain under these chassis whenever you get rid of all the old big capacitors and replace them with small ones. And we're back to playing again. Now that's static, there's thunderstorms in the area. Another day of it today too. And here's what we get with the AVC filter cap loose. Some squealing and no reception. I touch its chassis, it plays. Okay, that takes care of the capacitor replacements, and I neatened up the filter capacitors a little bit. And unfortunately, we have some rubber wire that's degrading, and that's going to have to be addressed. As much as I hate doing it, it's got to be done. But first, let's flip it upright and turn it on and see where we are at this point. Alright, it's about 7 in the afternoon, and we're already getting some DX at the high end of the band.
When it was first, a new poll asks America's clergymen. I'd lost touch with God.
He advertised all the things we heard about him. We saw from our first meeting with him.
Isn't that an encouragement? And whether Alaska Native corporations are generally looking to federal funds to stay afloat.
Now something is wrong with this tuner. We get a little below 900 and it stops. So we need to address that. Probably right now would be a good time for that. Yeah, it looks like this tuning wheel is bent. And that could be the problem, so let me play with that and see if I can get it straight. Okay, that was very easy to bend, and I think we have it. Okay, there we go. So that problem's solved. Oh yeah, and during all these troubling times we're living in today, I thought it'd be good to get this in the video. On the top of the dial it proudly says, "Made in United States of America," which is something you don't see on electronics these days. Alright, I'm going to touch up the alignment. So far the IF seems to be pretty close. Yeah, the alignment seems to be pretty well spot on as far as the IF goes. Well, the oscillator tremor was a little off, but the rest of it wasn't too bad. And we're getting some R&B stations somewhere around 1320. Okay, well, this seems to be a good radio, and I'm more motivated to restore this one. Okay, this is the station out of Monroe, Louisiana. I think this is WABF out of Fairhope, Mobile area over in Alabama. Alright, I went in and cleaned up some more of my work, and the way I like to do components when the lead is not long enough is insulate a portion of the new component with sleeving or whatever, and then solder on our extension lead, and then slide a piece of insulation over that lead, and then slide a piece of heat shrink tubing over the solder connection, and that way it looks neater and it doesn't short to anything. And I've already started the rewiring process. The yellow wire you see here is the filament circuit. I've already redone that and the dial lamp. And it's basically just a self-explanatory. It just takes a while. You just want to make sure you cut your wire to the right length. Right now I'm kind of running low on the store-bought hookup wire, so I'm using wire that I've salvaged out of old TVs and junk that I've EOL'd. And the hookup wire comes in two varieties. You have stranded and solid. The solid hookup wire is okay to use under the chassis where nothing is likely to be moved. However, if you're using wire for, say, a tube grid cap or a dial lamp socket or a loop antenna, things that might, for whatever reason, be moved for servicing, I'd recommend using stranded wire because the solid wire is more likely to break whenever it's moved around. And the hookup wire usually comes in ratings of 300 volt and 600 volt. Obviously 600 volt would be better, but for most applications 300 volt will do okay. But you can see this red wire, how it's just flaking, and the red wire is what carries the high voltage, so we don't need that shorting out to anything. And on fragile components like this oscillator coil, I'm not going to attempt to heat this up and be wiggling on it trying to get the old wire out because I don't want to break the terminal. I'm just going to try to get a through hole through this terminal as gently as possible and poke my new wire through it, make a good mechanical connection, and solder it up. And on stranded wire, I like to, once I strip it, twist the strands together and then tin them so they can't come unraveled before we solder them to the respective connection that they're going to. And this one's going to be a bit tricky because we have several things tied to this one terminal strip lug here, which is a distribution point for B+. We have this resistor. We have the wire going to the oscillator coil that we're in the process of replacing. We have a wire going down into the IF transformer. And we have two other crumbling red wires that are going to various points. Now, yes, we will have to remove this IF transformer and take it apart and rewire it. And you see how this insulation is just falling off. When I move the wire, it just flies off of there, and that can be a dangerous situation. So best just to go ahead and rewire it, as tedious and time consuming as it is, and be done with it. Alright, I have that terminal cleaned off, and as far as what needs to go there, we have this wire, the new wire coming from the oscillator coil. We have this wire going into the second IF transformer that provides B+ to that circuit. We have this other wire going into the first IF transformer, supplying B+ for that circuit. We have this other wire going to the screen grid of the audio output tube, which obviously provides voltage there. And then there's a resistor taken off of the screen grid of the output tube that provides plate voltage to the first audio and detector tube. We have this capacitor here, which is our RF bypass capacitor on the B+ line. And then we have this resistor here that provides screen voltage to our IF amplifier and mixer tubes. So, yeah, quite a few things that go to that terminal there. Okay, here's the first IF transformer removed, and we're going to take it apart and rewire it. All we should have to do is remove this nut on top of the can, and the innards should come out. The red wire is pretty much toasted. The blue and the black one could pass, but if I'm going to go to the trouble to take this apart to rewire it, I might as well go ahead and change them all. And here it is apart, and in my opinion, this type of IF transformer is the best kind. Rarely do I find one that's bad. These are much better than the little permeability tune ones that they came out with in the late 40s and used up until the end of the tube radio era. Those little ones are the ones that are bad about having silver mica disease. Okay, there's the red wire replaced. And after each wire, I'm going to check the continuity of the coil just to make sure, because it's very possible that one of the small wires could break loose during the unsoldering and soldering process. And if I can check it after each wire replacement, and if something turns up open, then I'll know where to look. Hopefully won't nothing turn up open though. Alright, let me go try to find some more stranded wire. That's getting to be in kind of short supply around here. And finish this. I need to order some wire, but what Antique Electronics Supply wants for it is ridiculous. But I know they're also not the only game in town, so there you go. Alright, here we are rewired and put back together. All we have to do now is put it back in the chassis, and probably going to have to trim the wires down and restrip them for best fit, and reattach our tube grid cap, and this IF transformer ought to be ready to go. Alright, the first IF is done and installed. Again, I have not soldered this B+ high voltage junction yet because there's more things that have to go here. The AVC line was orange. I didn't have that handy. I just substituted a white piece of wire for that. Radio doesn't care what color it is, just so it conducts and has insulation on it, and it conducts and has insulation on it, so it'll work fine. Okay, here's the second IF transformer, and just like the first one, the wires are just as rotten as they can be. The only one that's in somewhat decent shape is the black wire, and like I've said in other videos, it seems like a lot of these rotten wires have to do with the color that they are. Like with this one, the black wires is passable, but the other wires are crumbling apart. Now, really don't make much sense unless whatever dye they used in the wire coloring, insulation coloring, has something to do with the insulation breaking down faster. Alright, second IF is redone. I substituted white for blue. All the other colors are the same. The red wire, I had to use a solid conductor because that's all I had handy. So I put a piece of heat shrink over it as kind of a bit of strain relief. Once it's installed, it won't be a problem. I just don't want it to break while I'm installing it. Okay, second IF transformer rewired and physically installed back in the chassis. And I've about had enough of this for one day, so tomorrow we will trim these leads down to the appropriate length and solder them where they need to go inside the chassis. Okay, we have the IF transformer wired back in circuit, and I had to take the volume control out in order to solder one of the wires back in place. And while I had the volume control out, I just went ahead and replaced the out of tolerance resistors that are connected to it and cleaned that up a little bit. So now we're ready to flip it back over and turn it on and see where we are at this point. Hopefully we didn't booger anything up.
I guess the big takeaway from the draft.
But what do you know? It still plays. I still need to mount this loop antenna. One of our mounting studs was missing, so I'm going to have to come up with something for that. This red wire needs to be replaced, as does this green wire here on the grid of the converter tube, and I think there's another wire or two under the chassis that needs to be addressed, but there's light at the end of the tunnel as far as the chassis repair is concerned. Okay, we've got two more pieces of wire to deal with. This blue one that runs from the oscillator coil to the converter tube socket. I may not even bother with that. I just may move it out of the way because it's really in no danger of touching anything, especially if I move it. And we have this green wire that runs through and solders to the bottom of the tuning condenser. I'll be honest with you, I'm not too thrilled about pulling the tuning condenser out and redoing that, so if I do anything to that, I may disconnect it from the oscillator coil and run a piece of tubing over the wire, so if the insulation does crumble, then it won't short to anything, but everything else is pretty much done. All this is cloth-covered wire going into the power transformer, and it seems to be okay, so we're not going to worry about that. Okay, I went ahead and re-sleeved that tuning condenser wire that was going through the chassis. Put it all back together after I glued the cabinet back. Now this cabinet needs some serious help, but not by me. Cabinet repair is really not my expertise. So now we'll take it up, plug it in, and see what we can get. And then we'll move on to the fourth and final radio in the group, the little 4-tube unbranded. Well, actually it was branded at one time. It just lost its brand over the years, and we don't know what it is. And I'm currently gluing this cabinet back together. Alright, so let's take the Majestic up and see what it'll do. It sounds like we're getting a little single sideband on the old police band that's up above 1700 kilocycles.
Sorry for my mama, she makes them off the line. You can find me in my wig. Now that we've got the clock, the relentless, the baseball. Take a picture of the yacht, right? Yeah, that was the, Speaking of those rolls, Jordan is delivered out from underdeckers, child soldiers. Over out. Years later.
So I have to really come up with different ideas.
So what happens is your stomach has one major job. Your stomach's job.
There's WSM at 650. Now this dial is not accurate all the way across the band, and that's typical for a lot of these. But it's pretty close. But this is not bad at all, considering it's only about 7:30 and not even dark yet. Well, it's about 8:30 in the PM, and just about the time I turn the camera on is when my country station decides to fade out. There's the other country station.
Her son was in his late 30s. He'd been smoking for years. He didn't think he'd actually be able to quit, but he did, and he never smoked again.
I have about a 6-foot piece of wire connected to the external antenna lead, and that helps a tad bit. The only thing only negative about connecting the external piece of wire is we get some of this squealing here.
Security researchers are looking for
There's WABF out of Mobile. Impressive. I'd like to leave it on there longer, but the copyright police might pitch a fit.
Had to be baptized to be safe. About the future is different.
Shut down.
To the World Health Organization.
Bernie, good luck with that. Bernie. Security products by calling
I'll be right back.
I think that's WSM. There's really not much at the low end. Yeah, that's WABF.
Cloudy Wednesday with a 50% chance for showers and thunderstorms, high 84. On the water, north wind 5 to 10 knots. Seas one to the west, stays in coastal waterways smooth. 90 meteorologist Q and Albany and WABF 14.
Yeah, there's WSM. They're kind of wanting to be a little bit bashful tonight. This is 1600 KLEB. I'll turn the radio, and WSM's coming in a little better now.
So I'm not trying to win it. I'm just saying you didn't really. I mean, you got to say people.
Implementing with astaxanthin.
It's probably
They were able to improve their
WWL.
accuracy.
And then this is not printing machine money here. This is real money.
Ending the trade and consumption.
When you say. Could be drafted in the amount. Some people mail in their mock drafts, and then I got lots of calls and all around over 200. But
We always thought each other
Alright, and that's it. Now the next on the agenda will be the little unknown brand one.
Trying to work from home?
I'm not home watching a lot of TV.
Been quarantined ever since. Hardly working.
Gotta get some coronavirus stuff in here before we end this.
I can use the money to buy some toilet paper. But we all wonder when things can return to normal.
And to pay the bills.
We'd love to ease your mind and give a bit of hope. Be